Here is a simple app I created to practice and demonstrate the implementation and benefits of caching across both server and client components in Next.js. Basically, I created a mock social media feed that loads generated post data from a containerized PostgreSQL database designed to simulate a real-world paginated content system with both server and client-side caching behaviors. These initial posts, which are displayed when the page is loaded, are cached at the server level using Next.js's extended fetch API and then served as static content. This allows you to define custom caching behavior and deliver prefetched dynamic data as static assets. Behind the scenes, this relies on incremental static generation, a rendering strategy where page content is pre-generated and can be revalidated either on a fixed interval, manually, or through server-side functions. In this video, I'll walk you through the performance benefits of incremental static generation, which allows you to rehydrate static content as needed. At the top of the posts feed, you can see a server cache timestamp variable, which is also incrementally statically generated. This timestamp acts as a cache key for cursor-based pagination and is referenced during data fetching to anchor all paginated queries to a consistent snapshot in time. Cursor-based pagination is essential for maintaining stable pagination even as new posts are added between fetches. By anchoring each query to a fixed reference point, such as a timestamp, you avoid the common pitfalls of offset-based pagination, like duplicate entries or skipped results that occur when the underlying data changes during navigation. When you refresh the page, you'll see that both the cache timestamp variable and the initially rendered posts remain unchanged. Even if new content has been added to the database in the meantime, no additional queries are made during the initial page load. Thanks to server-side caching, all users receive the same pre-rendered static web page until the cache for the corresponding server component is invalidated, triggering a background regeneration of the static content, which is then cached and served on subsequent requests. This approach significantly reduces database load, improves response times, and ensures consistent performance at scale. Because the content is delivered as a static page, it loads instantly for every user. Now I'm going to show you incremental static generation in action. I created a client component that randomly generates and seeds new posts into the PostgreSQL database, appending them to the top of the feed. When I refresh the page, those new posts don't show up. Instead, I'm still served the cached, statically generated data. Keep in mind that during this page load, no database queries were made for these posts. React server components have a feature called Server Actions. This built-in capability lets you run server-side logic, such as database queries or mutations, directly from either server or client components, without requiring separate API routes or client-side handlers. The Invalidate Feed Cache button is a client component that triggers a server action to revalidate the statically cached data for the current page. This action refreshes the server-rendered content and updates the cache timestamp variable used for pagination, ensuring future queries remain consistent. Because the action was initiated by the current user, Next.js streams the updated content, including the new timestamp and latest posts, directly to the browser. Instead of requiring a full page reload, the new data is streamed into the existing view in real time, allowing the feed to update seamlessly. Now, the next time this page is loaded, by me or any other user, the updated timestamp and latest post data will be served as static content with no additional database queries required. This new static content was generated after the server action triggered a server-side function that invalidated the previous cache for the route. Once invalidated, the old content was replaced with a freshly rendered version, which is now cached and served on all subsequent requests. As a result, pagination remains stable, the data stays up to date, and performance stays fast and consistent across all users. Next, I'm going to show you how caching works at the client component level. This project uses an NPM package called SWR, which stands for Stale While Revalidate, developed and maintained by Vercel, the creators of Next.js. SWR caches client-side data fetches across your application using the request URL as the cache key. This means repeated requests for the same data are served directly from memory, avoiding unnecessary network calls. If I scroll down, you'll see that I implemented the post feed component to dynamically load additional posts as the user approaches the bottom of the scroll container. This behavior is powered by the useSWRInfinite hook, which is an extension of the core SWR hook designed specifically for paginated or infinite scrolling data. Each page of results is cached on the client using a unique composite key generated from the page index state maintained by SWR and its request URL, which in this case includes a statically served timestamp to ensure pagination consistency. Now, scrolling back up to the top, I can click the Refresh Feed button to navigate away and then back to this page. This triggers a re-render of the underlying server component without requiring a full page reload. On remount, you'll see SWR in action. It preserves all previously fetched pages in memory and serves them instantly. And if this route's cached data is revalidated on the server, whether through time-based revalidation or any other server-side logic, the timestamp embedded in SWR's pagination query will become outdated. At that point, SWR detects the change, updates its cache key, clears its old data, and fetches fresh results. This keeps the client-side feed in sync with the latest server cache snapshot, helping to prevent duplication, gaps, or stale content. To conclude, this demo application showcases the benefits of incremental static generation in Next.js, especially when paired with client-side caching strategies like SWR while utilizing server actions. This approach allows dynamic content to be served as pre-rendered static assets, stable pagination to be employed using timestamp-based anchors, and seamless updates to be delivered, all while minimizing back-end load and avoiding unnecessary database queries. By eliminating redundant data fetching and reducing server workload, this approach to building and deploying web applications makes it much easier to scale efficiently and support increasing traffic without sacrificing performance. That's exactly why incremental static generation is such a compelling choice for applications that need to deliver fast, reliable user experiences while still supporting dynamic content. If you'd like to explore the code or try it out for yourself, I'll provide a link to the GitHub Repository in the description.